In a stunning development, NASA's James Webb Space Telescope has once again amazed the scientific community with a groundbreaking discovery. Just weeks after it identified what is believed to be the earliest known galaxy in the universe, the telescope has now detected something even more extraordinary: a supermassive black hole hurtling away from its host galaxy at an astonishing speed of 4 million miles per hour. This unexpected observation has sparked intense debate among scientists and space researchers, as it challenges long-held theories about the behavior and nature of black holes, and raises new questions about the structure and evolution of the cosmos. The James Webb Space Telescope, launched to study the universe's earliest stars and galaxies, has already captured incredible images of dying stars and ancient galactic structures dating back just a few 100 million years after the Big Bang. Now its latest finding has deepened the mystery of black holes. Typically, black holes are known for their immense gravitational pull, drawing in everything around them, including light. However, this newly observed black hole appears to defy that norm. Rather than pulling material inward, it seems to be leaving a trail of young, newly formed stars in its wake. This string of star formation extends a staggering 200,000 light-years behind it, leaving scientists both amazed and perplexed. A research team led by Professor Peter Van Dokkum of Yale University recently published their findings in the Astrophysical Journal Letters, revealing that the wake behind the black hole is likely a result of gas being compressed and cooled as the black hole plows through space, triggering star formation. These observations have been further confirmed by NASA's Hubble Space Telescope, providing solid evidence that the black hole is actively creating stars as it travels. This scenario is unprecedented and marks a significant shift in how scientists understand black hole behavior. But that's not the only major finding from the James Webb Telescope. Another extraordinary event has been captured: an enormous galactic merger known as ARP 220. This dramatic collision of two spiral galaxies can be seen blazing in infrared light, a wavelength the Webb telescope is specifically designed to observe. ARP 220, located in the Serpens constellation about 250 million light-years from Earth, is classified as an ultra-luminous infrared galaxy. Its brightness is staggering, equal to the combined light of 1 trillion suns, far surpassing the Milky Way's output of around 10 billion suns. Roughly 700 million years ago, two spiral galaxies crashed into each other, sparking an intense wave of star formation. This collision created a compact region just 5,000 light-years wide, packed with over 200 massive star clusters. That small area alone contains as much gas as the entire Milky Way. Prior studies using radio telescopes uncovered about 100 supernova remnants in this region, all within a space less than 500 light-years across. The Hubble Space Telescope later revealed that the merging galaxies have two distinct cores, separated by about 1,200 light-years, each surrounded by rotating rings of star formation, emitting brilliant infrared light. Webb's recent images show, even more, faint tidal tails stretching from the outer edges of the merger, evidence of powerful gravitational forces at work. Streams of red, orange, and other glowing filaments suggest scattered organic materials drifting in the chaos of the collision. In another shocking twist, astronomers using the James Webb Space Telescope have discovered primordial galaxies located at the very edge of the observable universe. When first observed, there was skepticism. Some researchers thought these might be nearby galaxies mistakenly identified as ancient ones. But upon further review and confirmation through shared global data, Webb verified their authenticity. These galaxies are indeed ancient, with their light having traveled more than 13.5 billion years to reach us. This gives astronomers an unprecedented look into the very beginnings of the universe, revealing how early galaxies formed not long after the Big Bang. Spectral data gathered by Webb confirmed that these galaxies lie at the edge of our current observational limits. Some are even more distant than anything the Hubble telescope could detect. These observations are vital because they help fulfill one of Webb's core missions: studying the early universe through ancient light. Webb's ability to detect extreme redshifts caused by the expansion of the universe stretching light into the infrared is what sets it apart and allows scientists to peer into these remote epochs. The excitement among researchers is tangible, as these discoveries mark a huge step forward in understanding how galaxies came into being. Webb's instruments, such as its near-infrared camera and spectrometer, have provided more insights. Of the 6 earliest galaxies detected, 4 exhibit extremely high redshifts, suggesting they existed only 300 to 500 million years after the Big Bang. These galaxies appear to lack heavy elements like carbon, pointing to a time before such elements were widespread in the cosmos. This raises important questions because the universe is estimated to be around 13.8 billion years old. The presence of such developed structures so early in time suggests we might need to reevaluate our models of the early universe. This has led to growing concerns within the scientific community. The existence of these large, ancient galaxies doesn't fully align with the standard model of cosmology, which includes the inflation theory and Big Bang framework. Some aspects of the Big Bang theory, such as violations of thermodynamics and the lack of a clear trigger for the initial explosion, are now under more scrutiny. Webb's detection of galaxies almost as old as the Big Bang itself is forcing scientists to reconsider much of what we thought we knew. According to theoretical physicist Michio Kaku, these findings challenge the very foundation of our understanding of the cosmos. It was once assumed that galaxies forming so soon after the Big Bang would be small and primitive. Instead, Webb has found several galaxies that are up to 10 times larger than the Milky Way, all within the universe's first half-billion years. Creating such massive systems was previously thought to take billions of years, which means we may have to rewrite the textbooks and revise our theories of how the universe began. Adding even more intrigue, NASA has recently announced the discovery of a galaxy cluster just 650 million years after the Big Bang. This fledgling cluster, observed through Webb's powerful instruments, is expected to grow into a massive system similar to the Coma cluster, one of the largest known clusters of galaxies. This particular region appears to be a hotspot of accelerated galactic evolution. Scientists have been able to measure the velocities of 7 galaxies within the cluster, confirming that they are gravitationally bound and forming what is known as a protocluster. To help illustrate this process, NASA scientists likened it to small drops of water in separate rivers eventually merging into a powerful, unified current. It's becoming increasingly clear that the Big Bang theory, at least in its current form, may not be telling the whole story. Webb continues to gather critical data that might confirm or challenge existing theories. While the Big Bang may still have occurred, the mechanisms behind it, and what came before, are now more mysterious than ever. We're entering a new era in astronomy, where the boundaries of our knowledge are being pushed further with each new image and each new spectrum of light captured by the James Webb Space Telescope. As the universe continues to reveal its secrets, it seems we are only just beginning to understand the vast complexity of how it all began.